Hi everyone, welcome to the Swift Arcade. I'm your host, Jonathan Rasmussen. Welcome back as we continue building out the Starbucks application. This episode is going to be all about core graphics. One of the key elements on our rewards tile here is this graphic here, which shows the reward points for someone who's been drinking a lot of coffee. And in this episode, we're going to see how we can draw this specific picture using something in iOS called core graphics. So if you've never heard of core graphics and you're not sure how it works, come on in and we'll dive into this really cool iOS technology. So core graphics is Apple's lightweight 2D drawing framework, and you'll see it used a lot in all sorts of applications. It's basically how we draw things in iOS. It handles everything from 2D drawing. You can do color management, there's gradients, anything you need to custom draw on the screen, you can do with core graphics. If you've ever been working in iOS and you see things like CG float, CG point, and CG size, that CG stands for core graphics, and it's really a core part of the iOS application. In our case here, we're going to use core graphics to draw that custom image that the Starbucks app uses to draw that rewards graph. But I think the best way to really get into core graphics is just to start with some very simple examples. So let's jump into the code and just see how it works. Okay, so what I've got here is a test application that I use to really teach myself about core graphics. Before building the Starbucks app, I have never played with core graphics before, so this was all brand new to me. But I found it's a really handy technique to create a brand new application, go in there, just play with the new technology, and then bring that knowledge to the Starbucks app, which is pretty much what we're going to do here. I've got some examples of how core graphics works, drawing things like rectangles, circles, squares, and doing text. And that's kind of what we need in order to draw this Starbucks image here. We're going to need to know how to draw some circles. We're going to need to know how to draw lines. We're going to have to add graphics and text. But if we can get the basic mechanics down of how that works, then we're going to be able to come back here and actually draw this image in our Starbucks app. So let's start with something really simple. Let's just start by drawing a simple rectangle and see how that works in core graphics. So here's a routine that does that. Core graphics is a really old technology in iOS, and what we need to do in UIKit is kind of bridge these two worlds. And that's what this UI graphics image renderer does. It lets us use this image renderer to create an image of what we're going to draw in core graphics, and then we can take that and set it on something that we know and understand in our world of UIKit, something like a UI image view. Drawing a rectangle, one way of doing it is just like this. You take your image renderer, you draw a rectangle or define the bounds of what you want to draw something in, and then you set these things called fills, strokes, and line widths, and then you basically call primitives on core graphics like add rectangle. And it will take the rectangle you defined, draw a rectangle, add it, stroke it out, and that's basically how you get something that looks like this. Here's how you draw a circle. We basically define the canvas or what we want to draw on, something which is going to be 300 by 300. We then draw our image by setting up some strokes and some colors. The fill color in this case is going to be red, the stroke color green. We set a line width of 10, and then we define a rectangle of what we want to appear. In this case, it's going to be a rectangle with an origin of 0, 0, a height and a width of 300. And then we just call this nice core graphic primitive called add ellipse in that rectangle, draw the path with a fill stroke, and voila, we get an image which we can set on our image view. Images and text, no problem. We can do that in core graphics too. We can define our canvas, in this case, something 256 by 256. We can take an image renderer. And the way we do this in core graphics is we use NS attributed strings. Do you remember those a couple episodes ago? Attributed strings is how we styled this balance view here, this 12. With attributed strings, we can set very specific attributes like font, size, coloring. We can control paragraph spacing and things like that. And it's another form of text that we can add to things like UI labels, buttons, and in this case, core graphics. So here we can define something like a mutable paragraph style. We can say we want it to be centered. We can then define some attributes for our NS attributed string, like a preferred font, along with that paragraph style. Then we can define an actual string and set the attributes on that string. using this code here. This is an attributed string using the attributes we've defined up here. Then getting back into Core Graphics world, we can actually take that attributed string and call a draw method on it. I find this really, really interesting. We're actually going to do a draw on our attributed string, passing in these options. We can set a position of 32, 32, a width and a height, and then we actually can add a graphic to it, in this case a star, and position where we'd like that star to appear relative to our text. If we do all that, we get back an image, we can set it on our image view, and then present it in our UIKit canvas. Okay, so now that we've got some basic fundamentals of how Core Graphics works, and don't worry, I know we're not experts in this, we've only started playing with it, but we've got the fundamental tools and some nice hello world examples of how to do some simple things. Let's now go see and talk about what it takes to actually draw something like this. So the big thing to understand about Core Graphics is what you see is what you get. Meaning if you want to draw something on the screen, you have to define everything about it yourself. So it's very meticulous, it involves a lot of math, and you have to be very precise. So in this case, in order to draw that graphic, we need to figure out the points and position of all the elements in here. We need to figure out what these line segments are, where these circles are, how they're spaced relative to each other, where to put this little graphic here showing where they are in the reward system, and then finally some text down at the bottom. We need to figure out the positions of all that ourselves. That basically means doing some math. Now the good news is the math isn't that hard. It's just math, and you have to be very precise. So the main challenge with drawing the graphic here is we really need to figure out dynamically what the segment widths here separating these circles are. So if you think back to high school algebra, we had these equations where y is equal to a function of x. In this case, the y, which is our entire frame width here for this phone, which is 414 points, we need to come up with an equation to figure out what's the space of x here. So we can write a simple equation for that. We can basically take what we know and basically look at how we want things spaced out and come up with an equation that where basically the frame width here, the entire width of this frame, is going to be equal to some padding on the left and the right. In fact, we're going to have two paddings, and then we're going to have 1, 2, 3, 4 line segments, plus a little bit of spacing of 0.25 on each side. That's what gives us the 0.5 of the 4.5 here. That's the equation we can use to then solve for this x here. So if we just rewrite this a little bit, x, or the distance between the dots, is going to be equal to the frame width minus 2 paddings divided by 4.5. We're basically solving for x. And this is the kind of stuff you need to do with Core Graphics. You just need to sit down, grab some pen and paper, and work this out. So when we get into the algorithm and actually show you how we do this, one of the things we're going to do is we need to also calculate the position of these dots. So once we've solved for x, and say that we know the distance between the dots is roughly 85, then we can basically calculate the position of our dots by looping through the number that we have and just doing some appending, figuring out the x and the y, and then collecting those into an array, and then we'll know our dot positions relative to each other and the spacing between them. Now, one little wrinkle about using Core Graphics and doing this is when Core Graphics draws, it likes to straddle or put half of the image above the line where it's being drawn and half of it below. That's why you'll see some offsets in here. Basically, when you draw a circle or even a line in Core Graphics, half is going to be above and half is going to be below that straddle. So you'll see some adjustments in there where in order to get the circle or the line to be completely within the bounds of the rectangle that we draw, you just need to make some adjustments. And this isn't something you'd be expected to know off the top of your head. This has just basically come to me by sitting down, drawing some shapes, realizing that half of my shape is outside the bounds of my rectangle and half of it is in, and then I need to offset it and bringing it down. Another way of looking at it is like this. When we draw our dots like this, if we were to initially draw it, it would appear like this. But in order to get it positioned exactly where we want it, we just need to do a little bit of math and adjust some offsets and bring it back up. Then really, it's just taking all that information and calculating all those little bits. So for example, to figure out these beginning and end segments, we're going to write some code that basically just marches along here and figures out, based on what our padding is, which in our case is 16, figuring out where that short segment is. And then because we know the distances of the line segments, we can also figure out the lengths of these last segments on the right-hand side here. This is stuff we just need to figure out. And I don't want you to think any of this was easy. This took a lot of time. I really had to sit down, work with pen and paper, bang my head a lot. And it took the greater part of a day or two to actually sit down and figure out the math and draw all this stuff. So when you get into core graphics, I don't want you to feel discouraged. I know I'm going over this very quickly at a high level, but I'm just trying to give you the basics so you understand some of the mechanics behind how this works. But don't for a second think any of this is easy or trivial. It's not. So with that, let's just go in there, draw the basic rewards graph now, and then there's one more little twist I need to show you at the end before we can bring it all together and see how it works.
Red 5, I'm going in.
Okay, so last we left off, here's what our view currently looks like. Our graphic view is this red box sitting in our app here. It's just a plain old view that we've defined in our reward tile view. And what we're going to do now is we're actually going to create the real graphics view here. We're going to create the real one now and actually add it in. So let's go to our rewards directory. Let's go Command N, and let's create a new file, and let's call it rewards graph view. Let's bring that in there. And apologies, I'm just going to copy in a swag of code here, and then I'm going to explain to you what is going on with all of this. It's just going to save some typing and save us all some time. But basically, this is just a view that we're creating, which is going to basically contain this graphic. And ignore this frame information for a second. We're going to go over what happens there in just a bit. But basically, this is just a plain old view that we're creating with our regular initialization. We're doing our same layout and work type stuff, and we're setting some constraints. And basically the bulk or the magic, instead of drawing circles and squares, we're drawing our graph view comes in here. And here's all the math in all its glory that actually draws all those dots, all those shapes, and does all those calculations that we saw in the demos. Let's just walk through it at a very high level just so you can see what's going on here. So at the very top, I'm just defining some attributes to keep track of things like padding, dot size, line width, number of dots. Number of dots is hard-coded to 5, and then the number of sections is going to be 5 minus 1, 4. So there is going to be 4 segments going across here. And then remember that y is equal to mx plus b equation where we need to decalculate the line segments? Well, here it is right here. The space between the dots is going to be the frame width minus 2 paddings divided by the number of sections, which in our case is 4, plus 0.5. That's how we're calculating the segments here. The short segment length, that's going to be equal to the spacing between the dots multiplied by 0.25. That's just a calculation I made to basically say that's how long I'd like this thing to be. And then here we're getting into the core graphics world. We're defining a renderer. We're defining an array to help us position and figure out where our circles should be. And then here is an array of strings, which is just going to contain the labels that go along the bottom here. And the rest of that is just basically math. Here's an offset indicator. This is the spacing that pushes all of these graphics down in order to fit this little green indicator here. That's just some spacing I needed to make sure everything fitted within the rectangle. And then basically, once we've got our image renderer here, now we can go ahead and do the math to define our dots. So here we're basically figuring out the X position of each of these dots by taking into account the padding, that short line segment here, the space in between the dots based on its index. So if the index is 0, the very first position X is going to be right here. What if the index is 1? We're going to add space in between dots of 1 and come out to here, and so on and so on. Then we can define the lines between our dots. So we can set a line width, we can set a stroke color, and basically get ready to draw these lines. Here's the math for our starting segment. The very first short segment here, this little one here, is just going to be equal to a padding of 16. And then where it ends is going to be the padding plus the short segment length divided by the dot size of 2. That's going to come up with the ending right here. And it's really just going through and doing this for the end, drawing the lines, doing the strokes, filling the colors, drawing our dots, and basically just by taking it step by step and drawing this graphic incrementally, I found that was the best way to go about it. Of course, I didn't do this all at once. I had to start with just a simple line segment, just this little bit here, adding the dots. But as you go through, and I find it really handy to do this on a separate view controller and a separate spike, just so you can see what things are going on. Eventually you'll be able to go through, figure out things like, how do I draw this little green indicator up here? Well, I'm going to need to figure out its X and Y position. Here I can grab the image. This is a graphic that we added into our assets. We can then draw it like this. And for our labels, we can just take that spike we did for the labels, do our NS attributed string stuff, and then for each dot, go in there and figure out the position of the label. And at the end of the day, we get an image that we can drop in here like this. All right, let's go see what this graph view actually looks like in action. Let's go back to our rewards graph. Let's go back to our reward tile view where we set up all the controls here. And instead of creating just a plain old UI view here, let's add in our rewards graph view. I'm just gonna give that a Command B just to get that to compile. And let's go ahead and lay that out. And it turns out we've actually got this pretty much already laid out in our app, which is really nice. There's just one constraint we commented out down here on a rewards graph view. We had this width being set equal to its frame width. I'm going to go ahead and comment that in now. I'm going to delete the line where we hard-coded the height to be 100. I don't think we need that anymore. And let's just run that and see what that gives us. Okay, not bad. We've got our graphic in here. It's showing up in our red background here, but you'll notice it's very small. It doesn't span the entire width here. And the reason for that is a very subtle point that I'd like to go over with you now. The reason why this is so small and not spanning the entire width is when we did our core graphics draw, we didn't know how wide our device size was. In other words, when we went to go do our core graphics routine, we didn't know what the frame width of our phone is when we drew it. Remember, these devices can have all different sizes. We could be on something as small as a 5S. We could be on something as large as an 11 Pro. And each of these have different widths. And core graphics, being as precise as it is, it needs to know exactly in the X and the Y where you want these things to be positioned. So how we can deal with that is basically, because we don't know when we start, we can set an initial frame width and just guess. In this case, I'm just picked a number like 200, and I assume that the width of this is going to be 200. I know it's not at runtime, but I'm just picking something smaller so you can purposely see the difference. So by setting a variable called initial frame width and giving it a core graphics float value of 200, we can then create an optional called the actual frame width that we can get once the device has rendered and we really know how wide this phone is at runtime. And the way that comes to us, or the hook, is in this layout subviews. Layout subviews is a function that gets called during the draw process on screen for UIKit. And when we're in there, we can grab our actual frame width, set it to that variable that we defined, and then redraw the graph. And that's how we can get an actual frame width to be defined and actually have that thing draw itself again once we know the frame width. And you'll see that we basically set the frame width as a variable in our draw rewards program based on whether we have the actual frame width or the fake initial one we created. It's an important but very subtle point, And it's just something sometimes you need to wrestle with and work out when you're working with core graphics. So let's go ahead and add that functionality now. So coming back to the code, we're still in the reward tile view. Let's go down here just beneath where we do layout, and let's override that layout function, layout subviews. We're going to call super on our parent just to continue the calls of layout subviews. But then we're going to take a rewards graph view and set that property of actual frame width to be our real frame width. And then we'll draw the rewards graph again. I also just want to see if we can get rid of the system.red color. We don't need that on our graphics view there. Let me just clean that up. And if we run this now, and voila, there we go. We've got our graphic. It's spaced properly. We've got our indicators. Everything's colored. Labels are there. Good stuff. We were able to add a core graphic to our Starbucks app. There's just one more little refactoring I'd like to do before we wrap up for today. I've been a little bit inconsistent in what we titled rewards graph and reward tile view in that. I'd like to actually just flip to the plural of rewards. So I'm just going to rename reward tile view controller to rewards tile view controller. I'm going to stick an S in the file name here also, just to make that consistent. And then the same thing for our reward tile view. I just want to call that rewards tile view. Sorry for the confusion. I just wanted to do that just to be consistent with what I was calling everything else. So rewards tile view there. We have to do that also on the extension here. And if we compile this, the compile will tell us where we have failed. So I'm going to come over here and just make that adjustment here. And also rename in our home view controller, reward tile view controller like that. And if we run that, that renaming should be done. Voila. Okay, let's just wrap up what we did here. We took a crash course in core graphics. We were able to add a core graphic to our app here that at runtime figures out how wide a device is, dynamically calculates and figures out the width of these segments, the location of these circles, where these labels should be, and draws it all out beautifully, dynamically in an app at runtime. Now, I know what you're thinking. Jonathan, we did this very fast. I still don't have a great grasp on how core graphics works. Don't worry, neither do I. It took a lot of time to draw this, and there's no shortcuts here. You're just gonna have to bang your head on core graphics, play with them a bit, figure out how they work. But I think one thing that worked really well for me was just creating small little sample applications, playing with this, drawing simple shapes, and then taking that knowledge into the real app when you go ahead and do it yourself. There's nothing to be intimidated about core graphics. It just takes time, takes patience. It's like any other low-level technology in iOS. I don't use it a ton on apps because there's not a lot of times I have to do this. But on 2 professional apps I've built, I have needed to do things like this, draw bar graphs, and it's just a handy tool to have in your back pocket for those times you do need to pull upon it and draw it out. And hopefully this example will show you some of the mechanics behind how it works. Okay, thank you so much for coming, everyone. We'll see you next time when we're going to dive into and see how to do this cool animation on our reward options. All right, take care, everyone. Thanks for coming. We'll see you then. Bye-bye.